That's going to be tough. Close enough. Okay.
All right. What else do I have here? Yeah, so I wrote synthetic or inorganic fertilizers are usually more concentrated than organic, easier to apply, because what could you probably do to this? How would you disperse this versus organic? You could spray it. Could be like a fine grain or pellets. I remember I used to use this stuff. I told you that. I had a spreader. It would just fly out. You have manure spreaders, but anyone who's experienced using those things, it's way more difficult than this, okay? And some of this is liquid. You could just spray it, very like that lady across the street. I don't think it was fertilizer, but anyways, it's more easily applied. Nutrient content can be controlled and targeted to certain crops or soil. So if you need more phosphorus or more nitrogen, let's say, you can use different types of fertilizer. Where the manure, the crop, it is what it is, right? So those are kind of the benefits of this. What about negative impact on the environment? So the negatives of using fertilizer in general, and then specifically synthetics. What do you think? Negatives or impact on the environment? What do we got? Yell them out. Runoff into water sources. That could be a variety: ponds, rivers, lake, ocean if it's on the coast. What else? Something we learned a long time ago, early in the year, can cause algal blooms, eutrophication. That's part of this, but what's happening there? So you're running off because what are you disrupting? The balance of the nutrients in the water, right? So disrupting nutrient balance and those cycles, right? So we're not supposed to have a lot of phosphorus. Phosphorus comes basically from rocks that wear down. It takes thousands of years. So if we're just injecting phosphorus into the environment and increasing that concentration to grow crops, it makes sense. I get it, right? We understand the reason. But if it's running off into other areas and it's not using that phosphorus and it's only supposed to be a small amount, we're disrupting it, that's going to cause problems like the algal blooms. Which, again, those are kind of connected. What else? Synthetic. What's the big problem? It's right in the definition. Yeah, using fossil fuels, which increases pollution, and the abbreviation is GHG. Greenhouse gases, right? Greenhouse gases, right? The more you burn, the more greenhouse gases are going to be produced. The thing with the runoff here that I found is that inorganic is more likely to run off than organic. So that was something I kept finding and reading over and over again, that the synthetic will run off. It's a lot more susceptible, and it does depend on, I guess, let's say, how soon you put this fertilizer on and then when it rains, right? Does it have time to absorb? You need a little bit of water usually for some of this to get in there. What else? What's another negative? Okay, think this. What can that impact besides eutrophication and screwing up the balance? And sometimes we don't think of this as part of the environment. Humans. Humans can be harmed. How? What do we do with water? Drink it. Drinking water. All right, fertilizer can run off and can get into drinking water. One more thing I have here. I'll read you what I wrote. It says, do not add organic matter to soil, only specific nutrients. One negative example is organic matter can increase cation exchange and water retention. So what I'll put here is cation exchange. I'll just keep it simple. Cation exchange. You guys remember what that is? Can be disrupted.
Exchange cations of one beaker to another.
Yeah, as far as soil is concerned, Clay did a good job with this. Well, yeah, base saturation. It has to do with how well the water can be retained. How well water is adsorbed, right? What's that mean? It stays on top, right? How well water can be adsorbed or retained. So if you have ions, so when you have an inorganic fertilizer, they come in compounds, right? So let's say potassium nitrate. All right. So K plus NO3. So you have other ions that are getting in the ground, and you don't know what, and I don't know all the answers either, what they could be doing, right? So just this is something I found that it can kind of disrupt the natural process of absorbing or adsorbing water because you're adding these different ions. So that can happen too. And organic can do that as well, not just synthetic. So in general, the negatives are kind of for both, but the synthetic have more drawbacks because one, it's artificial and made of chemicals. Two, they're easier to be run off. And three, you're using fossil fuels. So for example, if you use cow manure, you already have the cows on the farm doing something, whether it's for dairy purposes or you have beef or whatever it is. They're there, so you can use their byproduct. So you're not really you're not using fossil fuels to make the manure. They're already there. So the synthetic has some negatives that the organic does not have. All right. What else? What else? Liz, anything I'm missing here that you can think of? How can we mitigate this? What's mitigate mean?
Make it less.
Yeah. So how can we
Stop using fertilizers.
stop using synthesized fertilizers?
Plowing it under so that it can't run off.
Okay, plow it under so it can't run off. Good. What else can farmers do? Sometimes they have to do. I don't know if you guys.
can put it in this, like, inject it in the soil. There's like machines that.
That's like the no-till machine.
Yeah.
Kinda. You don't have to disrupt the soil so much, and you
Yeah.
put it directly like right next to the roots. Yeah, I've heard of that. Good. Now, some farms, don't they have to build drainage to collect
Like around.
possible
the field.
runoff? Yeah,
Yeah.
yeah. I know
When
Mr.
you're
McConnell
plowing,
talked
you
about that.
naturally, like, cause you're turning over the soil, so you always have like an outside kind of ditch.
Like almost like perimeter. So unless it's like
'Cause you're,
super
like-
flood,
So
it'll
when you
catch.
plow, you like scoop it and you flip it over.
Right.
Over here.
So then you have that
you
negative
don't
space,
want-
the
yeah.
void or whatever. Yeah, so, but yeah, okay, good. I mean, that's great. So, Mr. McConnell talked to me though that, you know, there are regulations that if there is a lot of runoff, you know, farms will sometimes have to have drainage ditches or some collection area so that it isn't going into all the waterways of the nearest, spring or whatever, stream. Yeah, how can we mitigate it? We can stop using synthetic, so that would help runoff, help this, stop using fossil fuels. That would help humans drinking fertilizer, eutrophication. So stop using synthetic would help a lot. All right, but over fertilizing, I'm sure that happens, and there is too much running off. That's a problem, and like Liz said, you can inject it directly into the soil near the roots. That would be a positive. So remember, in this class, we're always thinking, what's the positive as far as how can we help it? Because some of this is a necessary evil, but how can we help and do a better job? How can we make it better, right? Questions on any of this business? Fertilizer. Okay, let's see. So we talked about tilling, we talked about slash and burn, we talked about fertilizers, mechanization. I gotta give this guy props here. Norman Borlaug, Nobel Peace Prize in 1970. He bred strains of wheat that became resistant to disease and produced higher yields. He also started messing around and learning how fertilizers worked and irrigation methods, which we're going to talk about next. But he was a big part of the Green Revolution. I kind of skipped over that in my notes yesterday. So 1914 to 2009. Good for him.
95.
Yeah, that's what I'm shooting for. I got I read a thing on my phone the other day. 105-year-old woman renewed her license, and her quote was, she said, "I'm not going to just sit around." So, but hopefully she's not, driving 10 miles an hour to 55. Because that
Hopefully
happens.
she's like, not driving 50 miles an hour to 45. 'Cause
Typically, old people don't do that, but they're pretty scared.
why is she driving at all?
She said she wants to sit around. Well,
Yeah, but is she capable?
Yeah, is she capable?
they won't give you a license unless you pass.
Is she C?
They won't give you a license unless you
Oh,
pass.
come on. We both know they have you read the little chart. There's big difference between that and like.
I like to have faith in the system. They're not giving license to blind people. Yeah.
Okay, this guy invented, pretty much, he invented GMOs and he lived to be 95. Just saying.
Maybe you didn't eat them.
Mm.
Just because you invented it doesn't mean you eat them.
Um,
Kind of like the people who sell us oil use renewable energy. So there's that.
Hey,
All right.
they know what's best.
Okay.
Ruin their profits.
Right. They don't want to use the oil because they're going to save it to
Yes.
sell, and then they're going to live
Exactly.
off.
They're gonna make more money.
I mean, they live in the desert, so what's the most?
The sun.
Yeah, solar power, right? Even though it's not that efficient. All right, here we go. Irrigation. All right. So where are my irrigation notes here? All right, here we go. So go ahead and write this down. So irrigation, there are 4 methods. We're going to learn them. I have learn about them. I have pictures, images here. Waterlogging and salinization are negatives. So they get right into the negatives, which, it's good to know all positives and negatives. I wish they kind of explained it first. That's why the PowerPoint is very useful. I like it, like using it, but there's a lot of stuff that's missing. You hear me say that all the time. So, irrigation creates certain problems, including waterlogging and salinization. If you over-irrigate, form of soil degradation occurs when soil remains underwater for prolonged periods. So before you write the salinization definition, under waterlogging, let's make sure we really understand why that's bad. Because sometimes I read something out loud, I'm thinking one thing, and I'm like, oh, that makes sense to me. Well, I already did the research and read and learned about it, and I'm the teacher, so you may not be thinking the same thing. So I want to make sure you really understand that, even though you may know what the word means. So waterlogging is a negative consequence of irrigation. Irrigation was not always done. Farmers were just relied on what?
Rain.
100 years ago. Rain. And maybe they were doing rain dances. I don't know. I'm trying to get us rain. I don't know if that's something.
Just can't prove it didn't work.
What's going on with this waterlogging business here? So why is that so bad?
The water gets waterlogged.
Yeah, it drowns.
The nutrients will wash away.
Okay, nutrients will wash away.
That's
Like trees.
What do the roots and plants need besides water?
Air.
Air, specifically
Oxygen.
oxygen, right. So if it's underwater, it's not getting any. So make sure you put that down. It needs air, it needs oxygen. So waterlogging is a problem if it remains underwater for long periods of time. Now certain plants can survive in this type of environment, but most crops cannot, not for a prolonged period. So you need oxygen to get to the roots as well. All right, salinization. Form of soil degradation that occurs when small amounts of salt in irrigation water becomes highly concentrated on the soil surface through evaporation. So this confused me a little bit, and the reason it confused me, I kept thinking of the ocean. I'm like, what does the ocean water have to do with freshwater irrigation? And it has nothing to do with it. Where's the salt coming from? Not the ocean.
The ocean water.
Nope. We're talking, let's take the middle of America, the plains, where a lot of crops are grown. There's nowhere near the ocean.
But
Not the air.
nutrients that are
the rocks and minerals in the soil, the nutrient. There are salts in the soil, and when you irrigate, those salts can dissolve in the irrigation water, and when it gets to the surface and the irrigation, the water evaporates. This is chemistry. You evaporate the water, the solvent. What's left behind? Solute, which is the salt, and that can build up over time. So if you keep irrigating, it'll dissolve more and more of the salts. So that's a problem because that's essentially toxic. So that's not going to work. All right, for the crop. So I wrote form of kind of the same thing. Form of soil degradation, and the soil over time can become toxic to plants and roots if enough of the salts are deposited. So essentially, the irrigation brings it out because it dissolves, and then when the water evaporates, that's left over. All right, so those are the negatives. Positives of irrigation. It's pretty obvious. You're giving the plants water besides rain, so you can grow crops whenever you want. You could have a drought. If you have a water source that you can irrigate, then you can grow your crops. Tom Selleck.
Mustache.
Yeah, Magnum PI. Great show from like whatever, the 70s. Except they wore shorts that were like super short, and he had a big bushy mustache. He was like the man back then. Anyways.
Yeah.
Yes, Blue
Yeah,
Bloods.
Blue
Yes,
Bloods.
my mother-in-law watches that.
That's crazy.
Is that like Saturday nights or something like that? That's on?
I watch that all the time.
Yeah, I love that guy. Anyways, so yeah, he used to be a lot like thinner. He's gotten wider as he got older. He looks very different. The point is, he looked classic 70s into 70s. Now he's a bigger dude. Anyways, well, he was like thin with a bushy mustache, sunglasses, short shorts. All right. So, what did he do? Anyone? You said you heard. You know where I'm going with this? Apparently, he owns a lot of almond farms or farms. And California was going through a drought. It kind of does that periodically. He was taking water
From the almonds.
no, not from the almonds, from people and watering his almond trees. So it was a whole thing. It was in the news, and he was claiming he didn't know, and he's not there himself personally. So it came out that it was like really bad at first, and afterwards it sounded like it wasn't necessarily on purpose. I don't know. Anyways, the point is, in areas like California, when they undergo drought, this is happening. Farms are diverting water. Irrigation is a huge part of what we use fresh water for in this country. I had a percentage somewhere. Here it is, 75%. No, I made that up, 70%. I said 5. 70% of fresh water on Earth is used for irrigation. Just think about that for a second.
Let's see.
Oh, I do.
How much food did you?
Did you guys read the article yet?
That's a lot of water. I don't buy it.
You two with me back there? So the article talks about the amount of land we use for agriculture, and it's something, if you count livestock, make sure you guys check the oven at the end of class. If you but the land used for livestock and the land used for crops is South America and Africa. So the entire Earth, you take those two areas, that's how much we use for agriculture, and you need irrigation for that. You need water for the livestock, and you need to irrigate the fields. So that makes perfect sense to me. Most of our water is used for irrigation for agriculture. There's a quote in the book, I think somewhere, maybe I read it online, and I don't think this quote is valid, but the quote is agriculture humankind's biggest mistake? It isn't, because if you don't have food, you can't eat. But the point is, we can do it more sustainably, and we're going to talk about that tomorrow. Anyways, 4 types of irrigation. Anybody know? 4 types.
Hose.
Here's how bad it is.
Hoses are involved.
Water your fields with plastic.
Sprinklers can be involved.
Here's a lie.
I'll give you a hint. 2 start with an F, 1 starts with an S, 1 starts with a D.
What are we talking about?
Do you know these things?
What are we talking
I don't know what
about?
you're talking about.
Irrigation.
We were having our own
Methods of irrigation.
things. The circle things.
Aqueduct. Flood.
What?
Flood irrigation is one type, one method. Furrow is another.
Oh, that's what they do in like.
Spray is another. There's your sprinkler stage. And then drip, Kaylin, there's your hoses. Okay? Drip.
There's like these things and they put them on wheels.
Now,
Go around in circles.
To keep the notes kind of short and to the point here, flood is 70 to 80% efficient. Furrow, 65% efficient.
What is furrow?
Well, I'm gonna explain. Spray is 75. Now this one's a big range, 75 to 95. But it's closer to 75 from what I read. And then drip is around 95%. I was trying to do that in order and I screwed that up. Sorry. Furrow should have came first. Doesn't matter. This is the most efficient, also the most expensive. The least efficient ones are much easier and cheaper. So this is expensive and it's kind of difficult to set up. Once you get it set up, you're okay.
Can you explain what each of these are?
Yeah, I am. I'm going to. Give me the overview. I have the notes. I'm going to give you pictures of them. All right. What does flood sound like? You flood the entire field. Just flood it. Fill it up with water, and what does it do over time?
It seeps.
Slowly soaks in. Hopefully, if it doesn't, crops become
Waterlogged.
waterlogged. Right. Okay. Furrow is where you have these like trenches between, almost like you would see a field, if you can imagine a field, and I have pictures, and you have the crops growing, and then in between the crops, there's kind of like little divots between them, the negatives from the plowing you were talking about, basically. You fill those trenches up with water. So that's furrow. So you're not flooding the whole entire land, just these little trenches in between the rows of crops. Spray?
There's some dude with a hose.
Wait, what do you mean that's only 65% efficient?
I'm going to explain that.
Where-
You're antsy here, I'm getting there. Spray. What do you use? Sprinklers. Typically, have you guys ever seen, it's these big contraptions, these machines with pretty big wheels, and it kind of looks like a swing set thing, and then the sprays are hanging down, and am I kind of explaining that
Is
fairly
that
well?
the
And
one
it
where it
rolls.
rolls around in a
Yeah,
circle?
it can go in a circle or depending.
Yeah.
Yeah. Drip. What do you think drip is?
Hose.
You lay hoses in between and around the crops, and you basically like stab little holes in the hose so that, and then you have the water flowing very slowly, and it just drips out slowly and absorbs into the water. That's the most efficient because most of the water is in the hose and it comes out very slowly, and the crops absorb it and the soil absorbs it very slowly. So, Will, how come these are lower efficiency? What happens to the water?
Evaporates.
It evaporates. Think about if you flood a whole field, you're losing a lot to
No,
evaporation.
that makes sense, but why? What doesn't make sense to me is how furrow is less efficient than flood then.
So we're going to talk about that. But you would expect this because there's more surface area, right?
Yes, so
Yeah.
more would
Yeah.
evaporate.
Let's take some notes here.
Like
So,
furrow is moving.
all right. So furrow is the oldest method here. So let's, and I'll show you a picture here. See this, how does it not have images? That's wild.
That looks cool.
Alright, so there's furrow irrigation.
You know where we live?
Okay?
Yeah, you're right.
So that's furrow irrigation system. So you have your crops and then you throw the water between. It says this is very easy and inexpensive. So I'm going to write some things I won't, so you should write it down.
More water than I was thinking.
Easy and inexpensive. Farmers dig trenches or furrows along crop rows and fill them with water, which seeps into the ground. It's 65% efficient, 35% runs off or evaporates. My guess is because you're creating these channels, it almost gives it a path to run off. I didn't read that, but my educated guess
Yeah,
off the
well,
top of my head would be the
thinking-
runoff here would
Plus
be
the water's moving, right?
yeah.
So that means they'll evaporate more.
Yeah, so it might, yeah. So that's a great question, because I would, if I was to guess, if I said, all right, you flood the whole area, more surface area, more evaporation, but I think this has more runoff, is kind of why.
Where's it running off to?
Not the field, so everywhere else.
Stream they have a picture of?
Somewhere else.
That's
Somewhere
gotta be
else.
really
Dude, that's the
expensive
hose
to do.
reports coming in.
This apparently was fairly cheap and has been the oldest method. And mostly labor.
Well, yeah, they used to use it like back.
It's mostly labor, so people would have to dig that, humans, and then you would just essentially fill it up with water. So that's furrow. Again, remember, the percentage is how much they estimate the plants use. The rest is runoff and evaporation. So that's furrow. Flood, you can imagine what that looks like. So there's flood. I couldn't get bigger pictures, sorry.
The one on the right looks the same as the other one,
Not quite.
except there's no plants.
This looks a little bit more flooded.
Looks so, yeah.
than this. This looks very
Uniform.
like
Organized.
uniform and
If the other
organized,
one
right?
had plants, it
This-
would look pretty
So, okay,
similar.
look at the left picture then.
Okay.
All right, so flood an entire field, let water soak evenly. 20% runoff and evaporation. This can cause waterlogging. So flooding can cause waterlogging. All right, so I'm just giving you the main. You really just need to, once you see it, it's easier to conceptualize and understand. I don't have a ton of notes. So that's furrow and flood. I wanted to get through this quick. Spray. There it is. That's my swing set I was talking about.
See?
So there's spray irrigation.
Wow.
So I've seen those at work before. I drove to a Notre Dame football game once with my dad, and we drove through a lot of fields, and we saw it happening. It's kind of cool. It was like massive. It was like, this thing is, look how far it goes. But anyways, spray, water is pumped from the ground or well into spray nozzles and distributed across the field. So depending on the contraption, they vary. Essentially, it's like a giant sprinkler. It's more efficient because you can target and you can disperse the water a little bit better than just like flooding, for example. Obviously, I'm out of time. All right, moving on.
Go check her one.
Isn't that also that?
Oh, real quick, while you're packing up, what's